Today we're going to be talking about converting between fractions and decimals. This is not a calculator chapter. It will coming up soon, but for this one we are going to do this math on paper. If you would, please pull out your red pen, and I want you to fill in everything you see on the screen with your red pen. All right, so today we have a couple of vocab words that we're going to look at. Okay, the first one says terminating decimal. It's a decimal that ends. How many of you have ever heard of someone whose job was terminated? What do you think that means? Okay, he said he got fired from his job. That could be one thing. Another one, she said a job comes to an end. Maybe the company closed down. Whatever it is, okay, a terminated job means their job came to an end. In this case, you can see a terminating decimal is a decimal that ends. What example did you guys just write down into your notes? 4.75. Okay, 4.75, very good. That was a decimal that ended. Next up, a repeating decimal, all right? It's a decimal with one or more digits that repeats. If you look at this one, it says 1.36363636363636. It could go on and on forever, okay, because it continues to repeat. Now, there is an easier way to write that instead of having to write out a bunch of 3 6s. I want you to write a little arrow with your pencil and write this down, 1.36. Now this is called bar notation. When you put a line on top of it, the fancy way of saying that you just put up there was a bar notation, okay? Now that says 1.36 repeating, and we understand that that means the 3-6 is going to continue and repeat. So let's look down at these 3 examples at the bottom. 1.4. Do you guys think that that's terminating or repeating? Terminating, very good. If you would, underneath it, I just want you to write out that word terminating because it ended. It's a decimal that did not go on and on forever. It ended, so that is a terminating decimal. Let's look at B. 5.6 with a line on the top. What do you guys think? Repeating, okay? That is repeating because technically, if we had written that whole thing out, it would say 5.6666666, and it would just continue to go on and on. In order to not have to write a bunch of 6s, you simply put that little line on the top, and that says 5.6 repeating. Final one, Jocelyn, what kind of a decimal is that? It is a repeating one. Once again, you can tell that because it does have that line on top. That's 6.53 repeating. Okay, for the next section, we are going to write the fraction or the mixed number as a decimal. Okay, so first things first, I want us to go ahead and turn this into an improper fraction. Remember, when we have improper fractions, you're going to take this and multiply those two together. What's 4 times 2? 8. And then remember, you have to add that numerator. So what would that be as an improper fraction? 9/4. Okay, 9/4. And was that mixed number positive or negative? It was negative, so this is going to be negative 9/4. Okay, so now, how many of you would say that you are the oldest child in your family? Okay, very good. So, in your family, you probably have gotten to do things first that your siblings haven't gotten to do first because you're the oldest. It also comes with some responsibility. But as the oldest one, you typically go first, okay? So I want you to think about this right here as the oldest one, or the first one, which means if I am going to try to work out what this problem would be, I will always put the top number first, okay? So this means 9 divided by 4. A lot of people will try to say it's 4 divided by 9, but that would mean the bottom number is going first. Remember, just as you, the oldest child, goes first, in this case, the top number always goes first. Now, our goal right now is to turn this fraction into a decimal. In order to do that, I'm going to put a decimal after here, and just for our class, we're going to go 1, 2, 3. We're going to put 3 zeros. You could have just put 1, you could have put 5, 10, or 100 zeros, okay? But in our class, we're just going to put 3. If we need more, we'll use more. I want you to think about this decimal point like it's going up an elevator, okay? It's going to go up to the top floor, okay? Now, let's work this out. Guys, how many times can a 4 go into a 9? 2 times. What's 2 times 4? 8. What's 9 minus 8? 1. Is this 1 smaller than that 4? Yes, bring down one of the zeros. How many times can 4 go into 10? 2 times. 2 times 4? 8. 10 minus 8? 2. Is the 2 smaller than that 4? Yes, bring down another 0. How many times can 4 go into 20? 5 times. 5 times 4? 20. 20 minus 20. 0. Whenever you get to that bottom and you get a 0, it makes us very happy because that means we are finished, okay? Now, listen, I never want you to just box in on top of all that work, okay? Instead, you're going to rewrite the answer off to the side somewhere. 2.25. Is that my final answer? No, why not? I didn't put the negative. Remember, if the original problem was negative, the improper one was negative. That also means that my decimal, I have to keep that negative. So the correct answer is negative 2.25. Now, many of you might say, I already have memorized this fact. I want you off to the side, everyone, to write this. 1/4 equals 0.25. Then I want you to take your red pen and draw a cloud around that fact. Okay, you could write this anywhere on your paper. That's a fact that many of you might already have memorized. If you had memorized that, then you would know, looking back at this original problem right here, -2 and 1/4. You could have just figured out, okay, -2 is a whole number, and I know 1/4 means 0.25. If that was the case, you could have very easily just done that and skipped all of this work. However, if you don't have that memorized, this was the way that you could do all of that work. Okay, here's another fact that I'd like you to write down. 1/5. Do you guys know what that, or sorry, 1/2. Do you know what that would be? 0.5. That's another one that you can have memorized, okay? Put a cloud around it. That would be smart to memorize it. Then you wouldn't have to do all the extra work, okay? There's a lot of other ones you can have memorized, and it would be very helpful for you. If not, there is a way to figure it out. Let's come over here. Problem B, 5/11. Unfortunately, that's not one that we would normally have memorized. So how do I figure out what 5/11 would be as a decimal? What do I have to do? Divide, okay? This fraction bar means to divide. Which number should I write first, the 5 or the 11? The 5. Remember, just like the oldest person goes first, the top number goes first every time. 5 divided by 11. I'm going to put a decimal point, and in our class, how many zeros will we put? 3. 1, 2, 3. Now, you might want to write kind of tiny, okay? Let's bring that decimal up to the top. And 11. Can an 11 go into a 5? No. You could put a 0 here if you want, but you don't have to. Now we're going to focus on, can an 11 go into a 50? Yes. How many times? 4 times. What's 4 times 11? 44, okay? 50 minus 44. If you can't do that in your head, you can cross this out. 10 minus 4 is? 6, okay? Let's check. Is the 6 smaller than that 11? Yes. Bring down the 0. How many times can an 11 go into a 60? 5 times is correct. 5 times 11? 55. What is 60 minus 55? 5. Okay, the 5 is smaller than that 11. Bring down another 0. How many times can an 11 go into a 50? Not 4 times. 4 times 11 is 44. 50 minus 44 is 6. Unfortunately, I still don't have a 0 yet, so I can just keep adding zeros up here. I'll bring down another 0. How many times can 11 go into 60? 5 times. 5 times 11 is 55. 60 minus 55. Does anyone see anything here?
Yes.
A pattern. Listen, this will continue to go on and on and on and on and on. What kind of a decimal is that called? A repeating decimal. Do you guys want to keep going and keep finding out more 4s and 5s and 4s and 5s? No. How can you show me that you understand it's repeating?
Put a repeating sign above the 45.
Put that bar notation on top of the 45, okay? I'm going to write it off to the side, 0.45 with a line on top. And that tells me it means 0.454545545, and you get to stop doing all of the work, okay? So that was a repeating decimal for problem B. All right, on your paper, problem C, it says 1 and 5/27. We're going to switch that over to 1 and 5/10, okay? I want you to try to do problem C on your own and see if you can figure out how to write that as a decimal. Okay, so there was a different number of ways that people did this, okay? Many people went ahead and turned this into an improper fraction, which would be 15 over 10. How many of you would say this is how you started it off? Okay, then you would do 15 divided by 10. I'm going to put a decimal point and 3 zeros. As I walked around, some people did 10 divided by 15. Be careful. Always put the top number first and cover it up, okay? I'm going to bring that decimal point up. Now I've got 1 times 10. Bring down the 5. How many times can 10 go into a 50? 5 times. So 5 times 10 is 50. Once you subtract that out, then we are very happy because that is a 0, okay? So is this answer going to be positive or negative?
Positive.
It is positive, okay? Should I box it in right here on top?
No.
No, you're going to go ahead and rewrite it off to the side, 1.5, and box it in. All right, the next one's negative 6/5. What should I do, class? Divide. What do I divide first?
6.
6. Very good. So let's write it down. 6 divided by 5. We'll put our decimal point and 3 zeros. Go ahead and bring your decimal point up to the top. Let's do this together. How many times does 5 go into 6? 1. What's 1 times 5?
5.
5. How many times can 5 go into 10?
1.
How many times can 5 go into 10?
2.
2 times. 2 times 5?
10.
10. 10 minus 10? 0. Very good. What's the answer?
Negative 1.2.
Thank you for saying negative. Notice it was originally a negative fraction, so it's going to be a negative decimal, 1.2. Any questions on how we did that one? Okay, so this next little slide that I have here is about place value. It is not in your notes, but it's something that's very important to make sure you understand. Now, you learned this back in elementary school, but I do want to refresh your memory because sometimes we learn things and then we forget them, okay? So normally people would read this number and they would say 2.456. How many of you would have read it that way if I had asked you to read it? Okay, here's the deal. That's not how you would properly read that. If I was to properly read that, you would see the 2 is my whole number. The reason why that's a whole number is because it comes to the left of the decimal point. Now, all of these come to the right of the decimal point. That means they're only part of a number. So the proper way that I should have read this would be 2 and, this little decimal point says and, 2 and 456 thousandths. Here's how you can figure that out. The first number that comes after a decimal point is in the tenths place. The second number is in what place, class? The hundreds. Everybody, the last one is in the thousandths. Because this last one is in the thousandths, that means this whole number right here is in the thousandths. So you would properly read this as 2 and 456 thousandths. Okay, help me out with how would I read this? 1.32. What place is the 2 in? The hundreds, because it's 2 numbers away from the decimal point. So you would read that 1 and 32 hundredths. Very good. Okay, so now that's going to help us as we move on to this next part right here. Write the decimal as a fraction or a mixed number in simplest form. Let's talk about this thing first. What place is that last number, the 6, in? Hundreds. So instead of saying 0.26, that's a negative number, you would call that 26 what? Hundredths. Very good. And because it was a negative decimal, it's going to be a negative fraction. Now, from now until the end of your math life, you will always have to reduce. Remember, to reduce means to make something smaller. If you look at both of these numbers, are those both even numbers at the end or are they odd numbers? Even. Anytime you have even number in the numerator and the denominator, you can always divide by the number 2. Okay? If you're dividing by 2, you're simply cutting something in half. So let's see what this would be equivalent to or equal to. Once again, we know it's a negative, so I'm going to put my negative there. Let's cut it in half. What is half of 26? What is it? 13. Very good. What is half of my denominator, 100? 50. Now if I'm looking at the end numbers, are both of those even numbers?
No.
No, they're not. Is there anything that can go into a 13 that can also go into a 50?
No.
No, there is not. So this is my final answer, negative 13/50ths. So basically what that means is negative 0.26 means the same thing as negative 13/50ths. All right? Remember, everything that I've got on my board, you want to make sure that it is in your notes, okay? So make sure you're copying it down with your pencil in your notes. Let's go to the next one, problem B. We would normally read that as negative 10.25. But what would the proper way be to read that? Negative 10 and 25 hundredths. Very good job, guys. Okay, because this 5 is in the hundredths place, that would be negative 10 and 25 hundredths. Now, anytime you have a 5 and the 0 at the end, you will always be able to divide both the numbers by 5. But there's actually something that's bigger than a 5 that can go into both of those. Do you guys know what it is?
10.
Not a 10.
20. 15. 30. 35.
25, okay? At 25, think about it like quarters. Quarters can go into a dollar. We think of 100 like a dollar, okay? So you can divide by 25 on top and divide by 25 on bottom. If I were to divide by 25 on top, once again, make sure you're fair and divide by 25 on the bottom, okay? So we know we're going to keep our whole number, negative 10. Now, if I focus on this, guys, what's 25 divided by 25? 1. What is 25 divided by what's 100 divided by 25? 4. So the correct answer would be negative 10 and 1/4. Okay, let's go on to this next one down here. What place is the last number in? The thousandths. So to properly say this, this would be 125 thousandths. Do you think that can be reduced? Yes, it can. If nothing else, we can see that it's ending in a 5 and a 0 at the end. So for sure, a 5 could go into it. But there's something bigger than a 5. Guess what it is?
25.
25 could go into it. Here's what's crazy. There's actually something even bigger than a 25 that will go into both of those.
50.
It is 125. I want you to write this in there. Divide by 125 on the top. Divide by 125 on the bottom. Okay, so this is how we reduce it because there's a number that goes into the top and the bottom. What's 125 divided by 125? 1. Very good. Now we're going to think about this 125 kind of like 100. Let's just round it up, okay, or round it down. How many times can 100 go into 1,000? 10 times, okay? Now, this number is not going to be able to go into it 10 times because it's a little bigger than 100. Who would give me your best estimate or your best guess of how many times you think 125 might go into 1,000? 8. I think 8 is a good guess. Let's try off to the side. 125 times 8. 5 times 8 is 40. 2 times 8 is 16. Plus 4 is 20. 1 times 8 is 8 plus 2. Is that what we wanted? Yes, it is. So that is 8. Is this going to be a positive or a negative fraction? It is a positive fraction because we started off as a positive decimal. All right? Last one. We normally would read it as 3.1. But if we read that properly, how would we say it, class?
3.1.
Not 3.1 tenths. You would say 3 and 1 tenths. And that's it. That is your final answer right there because you just turned it into, as the instructions said, either a mixed number or a fraction. All right. Write the fraction or mixed number as a decimal. How can I turn 3/16 into a decimal, class? Divide is correct. All right. So we're going to put 3 first, divide it by 16. Let's put a decimal, and how many zeros should we try?
3.
Let's try 3 zeros. Jonathan, how many times can a 16 go into a 3? None, okay? You could put a 0 if you want, or you don't have to. Jonathan, how many times can it go into a 30? 1 time, okay? 1 times 16 is 16. And then we're going to go ahead and subtract. This will turn into a 2. That becomes a 10. Jonathan, what's 10 minus 6? 4. 2 minus 1? 1. Okay, let's bring down that 0. Guys, we're going to think about this 16 as a nice rounded number. If I were to round that 16, what would it round up to? A 20. Okay, it's near a 20. So now we're just going to take our best guess of how many 20s we think will go into 140. What's your best guess, guys?
2, 7.
7, 8. Let's try an 8. 8 times 6 is 48. 8 on bottom, 4 on top. 8 times 1 is 8, plus 4 is 12. All right, this looks like it's going to work for us, okay? 10 minus 8 is 2. 3 minus 2 is 1. Is that 12 smaller than the 16?
Yes.
Yes, let's go ahead and bring down another 0. Think about this 16 kind of like a 20. Okay, it's obviously a little smaller, but think about how many 20s would go into 120. 20, 40, 60, 80, 100, 120. So that's 6. Because 16 is a little smaller than that, we're probably going to add in another one. Okay, so what's our best guess?
7.
7. Let's try a 7 at the top. 7 times 6 is 42. 7 times 1 is 7, plus 4 is 11. And now we get an 8. We need another 0. I didn't have any more, but remember you can add as many zeros as you want from the top. Drop down that 8. Drop down the 0. 16 can go into 80 how many times? 5 times. 5 times 6 is 30. Carry the 3. 5 times 1 is 5, plus 3 is 8. Finally. All right, we got to the end. So now we're going to put off to the side 0.1875. Is this a positive or a negative answer?
Positive.
It is going to be positive, so I'd like you to go ahead and box that in. Okay, let's go to the next one. Negative 2 and 1/5. Let's turn it into an improper fraction. What would that be?
11.
Okay, negative 11/5. Now we're going to divide that. 11 divided by 5. You're allowed to put as many zeros as you want. In our class, we're just going to put 3. I want you guys to try this on your own. All right, Luke, how many times can 5 go into 11?
2.
2. 2 times 5 is?
10.
11 minus 10?
1.
1. Bring down the 0. How many times can 5 go into 10?
2.
2. 2 times 5?
10.
10 minus 10?
0.
0. When you get to the end and there's nothing else to bring down, you are finished. Luke, what's your final answer? Negative 2.2 is correct. Remember, write it off to the side. Thank you for remembering that negative. Okay? We're going to do just one more example. If you would, just put a little smiley face over here on number 4. We're going to just focus on this one as our last example. Negative 0.6. What place is that 6 in? The tenth. So what would this be? Negative 6/10. Can that be reduced? Yes, they're both even numbers, so you can divide both of them by 2 if nothing else. And if you did that, what would you get? Negative 3/5 is correct. Okay, because you just divide by 2 on the top and divide by 2 on the bottom. All right. You guys did excellent today. I want you to remember tomorrow, the only thing that is due is your purple timeline paper. Okay, great job today, guys.